you everyone for attending this session. So my name is Mingwei Zhang. I'm currently a senior systems engineer at Cloudflare. And this is the work that I've done before joining Cloudflare. And then the title, the original title of the work is Control Plane Triggered Traffic Performance Degradation and Detection. And then further on doing the work, I did a little bit software engineering to kind of extend to help the access of NDT data. So here's the summarization of what I've done there. Let's see. All right. All right, so overview of this talk. So its talk is separated by several different sections. I first talk about some data analysis of some outage events using NDT data, especially some of the network stableness even in early this year. It's a lot happened, so we want to know how much the internet changes or the world affairs affects what we can see on NDT results. And then we'll talk about a preliminary time series based on machine learning and then detection kind of a framework we can use to automatically detect abnormal events on NDT. And then we have a quick introduction to the NDTGuide, which is a Python templating library for accessing NDT on Google Colab platform. And lastly, some of the work that I've done during the time of the fellowship is to expanding how we can access the control plane data directly on any of the Python scripts or on a Jupyter notebook. And this will be helpful for further analysis, doing analysis on the control plane data or events. All right, so start with the NDT data analysis. So at the beginning, I took a look at how the Facebook 2021 outage affects the NDT data. So if you don't know that already, the Facebook 2021 outage is caused by an accidental PGP withdrawal of one or multiple Facebook DNS IP prefix. And as a consequence, the Facebook's internal and external services became unavailable and unreachable due to the missing DNS lookup results. And here are a few observations that I can see from the NDT data. The first is that there was a significant disruption of the Facebook services globally instead of regional disruption. And there were no significant internet outage as the requests of all the NDT data or most of the NDT data completed just fine. And then, so it's limited to the Facebook events or Facebook services. And the Facebook users associate, however, the Facebook outage with internet connection speed issues or internet outages. So they thought it could be like their internet issues, and thus reach out to do NDT tests, speed tests to confirm their suspicions. So what we can see from the NDT data is pretty obvious. So this is the graph of a NDT results volume graph over time. So we're plotting the time from about a month ago before the event to about a month after the event. So as we can clearly see that during the event time, which is October 4th, the request of the speed test spiked significantly, and it's 50% or almost 60% above the average, and 32% above the previous max data. So if you're interested in looking at more at this request or the data, there's a link. I'll share the link with everyone later. So the takeaway point is that if we see a significant enough events or outage events, we could potentially detect that using the NDT data. But if you actually see the internet outages, and then the NDT results will probably not going to be able to finish, then that can be a different issue. So I'm interested to look at more different types of events other than just a company specific events. So the next I've done this year is to look at how the Ukrainian networks observe it from NDT's perspective. So let me get the results first. So during the time that I was looking at, in the starting from early March to April sometime, there's no observable and significant disruptions that can be seen or observed from the NDT test results. This also matches with what the community outside were observing, is that the connection to the Ukrainian networks stays stable and connected in the most cases. So what I've done there is that I basically examined the test results executed from within the Ukraine, like a country inside Ukraine, and during the March 2022 timeframe, checking the mean RTT and throughput data over time. And I was hoping to see if there any kind of changes that can be detected. And as a result, there's no significant changes that can be observed during that time frame. And then there's also no significant changes in terms of the traffic volume, the NDT test volume there. However, although we have not observed any of those results, the volume of the tests were low. That's part of kind of the limitation that I can see with the NDT results, is that it's stable, but it's been less than 50 tests per day. So if you want to know anything that is more granular than per day level, we almost cannot do that because of the lack of enough tests. And then also, it's good and bad in that the test target selection is also pretty smart. So I was looking at some of the way that they're selecting test servers from the client, and it turned out that any of the AS level routing changes would make. I was thinking they might have caused like at least the throughput where mean RTT change, but the test switched to different servers that are always very close to the test clients. So in terms of performance, it doesn't really change much. And there's no observable changes that I can see. There are some changes in the control plane side of things. As we can see, there are some blogs about that. Here's a link about the one that I see, and then also the community saw during that later this year. I think it's May 1st. That the one of the Ukrainian networks switched the upstream to a Russian network. And although after the switch, the connection stays up, and then there's no significant speed changes on that. There are some other researchers, like for example, this one is from Romain from IAJ, that talks about how he can observe the upstream changes in terms of the control plane data. And you can see that they switched their upstreams during that time frame. But as a result, I think the conclusion or takeaway is that NDT data shows no significant changes for the network speed test from within the Ukrainian border. Okay, so next I'm going to talk about further look into the time seriousness of the NDT data. So because NDT data is performed by people, and people have daily patterns, so naturally we would expect to see that during daytime the test becomes more, and during nighttime test become less. And indeed, the NDT data volumes definitely shows the daily time series pattern. So we can basically use that pattern to learn about or train some machine learning model to detect significant abnormal changes automatically. And then, so during this research the work, I've been using or testing out this DARTS library for time series-based machine learning. And it's fairly simple. I'm no machine learning expert, but this one gets me started, and then it's proving to be pretty useful for my use case. So here's an example of events that I've been analyzing again with the NDT data. So I've been using the Facebook 2021 outage events, and then what we can see here is that I used the four weeks data before October 1st as a training kind of period, and then apply the prediction of this machine learning model for the week after October 1st, which also contains the event time. And from the graph, you can see that the blue line is the average predicted value over time for that week, and then the blue range is I think the 95% and then 5% range of those predicted data points. And then it's pretty obvious that during the event time, we can see that the data volume for NET test results falls way beyond the predicted range. A machine learning model like this can easily be applied to, say, detect such things without human intervention, which can be useful in at least as the initial steps for outage detection or like a I don't know internet routing changes detection. And this can also be the model can also be applied to a much longer period of time. And then so what I did here is to extend the training and the prediction to use a how to say a continuous training. So at every day I use the past 2 weeks. I forgot exact the window size. I use the past n weeks as training and then predict 1 day of the data. And then, as you can see, that we are seeing that the prediction is pretty accurate over time. And then we can also observe that on the right after event, the prediction specs up significantly because of basically the event pollute the training, and that thought we are actually observing or should observing this amount of data. But in fact, so this is one of the caveats. If we detect something that's significantly different than the pattern, we should also be careful whether to use it for the next round of training. Right. So I haven't done much more beyond this point, but I think for the interested person or people, we can start building things based on if your data or any of the other NDT fields shows daily pattern, then this can be applied and then used for machine learning based detection without human intervention. And then we could eventually build a pipeline that automatically alerts people if things are detected. So next, I'm going to talk about a new Python package that I built just initially for my own usage, because I'm no database expert, and then constructing SQL queries, it's always been difficult to start with. And then I figured that if people like me have multiple years of experience already having these troubles, and it will be difficult for people with less experience or technical background to do that. And I feel like this can be improved upon. So here's the library for that. So on a very high level, the NDTGuide is a Python package that aim to provide the easy to use and quick access to NDT measurements data on Google BigQuery. And then it is essentially an abstract layer or a wrapper around the Google's BigQuery interface and the MLabs data schema. And the goal for this package is to allow users to call functions and then predefined functions to get data or insights without writing raw SQL queries, although you can always write raw SQL queries if you find that the predefined functions are not enough. It's open source, and then I believe it's under MIT licensed. You can go to this link to check it out. There will be a demo after this slide, but I wanted to mention some limitations. So this package only works with the Google Colab for now, because of the way that the Google BigQuery authentication works. I was initially wanted to have it to be able to authenticate users without any human intervention, but it turns out that you always need a Google, I think, service account for that, which I find rather not convenient. Then there's a lot, potentially some hacks that can be done, but I haven't spent too much time on that. So as a result, the way that right now you authenticate users is to use Google Colab and in a more or less interactive way. And then I have started this project, but implement the limited functionality so far. So I'll introduce those later on. So for shortcuts, so to begin with, for all the data that we want to, so all the entity data we want to access on Google BigQuery, we need to authenticate first. And then I have kind of wrapped around this so that when you create the NDTGuide instance, you can just run the login command there. So it will basically guide you to the authentication place, and then you don't need to worry about remembering how to authenticate that. The next kind of a major functionality that I built and to fit my own research need is to gather daily entity data statistics. So it supports multiple tables. NDT5 and NDT7 is supported, and then you can specify a start and end date, and it will aggregate the NDT data over using different functions. It can average, max, min, and it can also have additional features based on country, based on ASN, and based on prefixes. So if you want to look at a daily pattern of a specific prefix, ASN, or country, you can do that as well. Here is an example query that basically asks for average measurements from NDT7 table between this 10 days period at the beginning of February for all the clients that are located in Ukraine. So it's relatively simple to understand. So you first specify a table name. I think nowadays all the new data is coming from NDT7 table, but I might be wrong. Then you specify date ranges, a aggregation function, and then later on, it's optional, but you can also specify either the client country or server country to find out all the results coming from a certain client or server. All right, I'll show you the live demo later on. I may move on to other functionalities. So for me, when I'm doing my research on different outages, I also find it's very useful to learn about what servers and the clients available that is doing for all the entity tests that are done. So it's not that we want to list all the available ones, but also want to know that for the existing tests, what are actually used during that time frame. So there is a couple of functions that you can generate queries to look for such information. For example, here's a question they can ask is to get all the servers where the clients located in this particular AS, that the clients that they in this AS used during the first week of 2022. So you know that what are the servers that are being used for for all the queries located from a network like this. And then it allows us to quickly find out what are the servers that used for clients for some network. And then it also works vice versa, where you can get all the clients that are doing any of the research for a particular server as well. So it's given a server, you can find a client, or given a client, you can find those servers. All right. And then lastly, NDTGuide also allows you to send custom queries or the raw queries if you want. To help with that, I also kind of embedded a schema function to get the data schema from BigQuery so that you can better construct your SQL queries there. To use it, you can just run the execute SQL command and then embed your SQL strings there. And then everything that returned from that will be a data frame. So it will be easy for analysts to plot and then plot the results, or kind of doing further analysis based on data frames. All right, so here's the demo. Right, let me see. So to use this demo, it's already published. Okay, see that. It's already published on PyAPI. So you use this demo on Google Colab. You just create a new notebook, and then you run this command where you install the NDTGuide, and then you create an instance there. Okay. So I'm showing that it's right now initializing a new container, and then it's starting from fresh. So none of this is installed. It can just run this, and then it seems like it's been working. And here's where I can see that you can log in. See if that works. Need to authenticate. Yeah. You may not see what I was doing there. It's basically doing a two-factor authentication on a separate window. And then once you're done with that, you authenticate with the Google account that is associated with I think the MLabs Google groups. You should see this authenticated, and then your guide, you need to get instance ready to go. So for example, this is the one that I showed you on the previous slides, where you can ask for the average test for clients located in Ukraine between these 2 dates. And then here, what I'm doing is printing out this raw SQL command so you can see what's being generated, and also run it, and then showing the top 5 results from the data frame. And this is happening in real time. It's querying the backend of the NDT on Google BigQuery. So because we're using average, you can see that we are showing the average throughput, average RTT, and then average loss rate. We could potentially get more fields if you want. We can easily extend that. So if you want to know more about what's going on with the time range, you can plot it directly. So for example, this one plots the RTT. And then get some data or plots the loss rate if you want. Right. So that's for getting daily stats. It's still pretty preliminary. If you any ideas that you want to explain, I kind of extend that. It's highly welcome and I appreciate it. And for this example, I'm going to show you is to how to get all the NDT servers that is being used during a time frame that is coming from any clients within the network. Right, that's the one I'm showing you here. So if you look at the raw SQL here, the filtering is pretty simple. And it's the filtering by dates and also filtering by clients network ASN. You can, there's a way to also, you can call this function by client networks country if you want. This is basically the way that we can see that if I'm interested in all the NDT tests coming from a certain ASN, I want to know where the servers are located that are being used for that, for those tests. So basically here, you get a list of NDT AS numbers, AS names, what are the servers that are located, countries, that. And the same thing can be done for the clients. Right, so this is pretty, let's see. Right, oh, okay, so this is only kind of showing you like all the clients AS number and the names based on the AS number. This might not be that useful anyway. All right, so the lastly I want to show you is the custom scope queries. So for a guide, you can also get print out a schema. This one might be able to do it. It's better printing. Anyway, so this is a dictionary, shows all the keys and values of things that are interesting that I see. And then you can construct your own queries based on the schema, and you can run your own queries there like this. And this is an example where it's the same example, getting all the average data, but the in this one, I'm extending that by adding a count column so that I can know that for each day, like how many actual results are being generated. So what you can do is basically copy what's generated, what's generated here and print that, and then extend it as you wish here. And then you can also plot like so the same thing can be done with the like event analysis, where this one plots the average, the count of NDT tests over time. So like this. All right. So that's the demo that I'm working on. Right. So let me see how much time I have. I'll be quick on the last few slides. So if you're interested in getting more kind of control plane data as part of the work I'm doing, because of it's tightly tied with control plane data, so I'm also being able to extend some of the work that I've done in Rust to gather like control plane data and then port it into Python so that the data analyst can also do some tasks directly on Python notebooks. So this is the work to adding a Python binding for all the Rust codes from PGPKit. It's basically a set of libraries, open source libraries that I built before, that I can work with MRT files, BGP MRT files, and also archiving and then indexing the existing ones that are available on RockViews and RockBase. I also added additional features to enable like a queries over historical RPKI data, so that you can do some more analysis on the routing security over time. So it's a way to easily access the public available BGP data. It can be tied with your analysis for NDT as well. And it is again runnable on any Python scripts or Jupyter notebooks or directly on Google Colab. Here's an example. I'll click on that. Labs. Okay, so same way as installing a different library. Okay, this one, it's already published on PyPI, so you can directly install it like this. Again, this is initiating a new Docker container, I believe, on Google Colab. So it's now there and it's installed, and then you can import that. Let's see. Yeah, it works. Okay. So once you install it, and then you can do some of the usual works that are involves with parsing a PGP message data. So this is what I usually do if I'm interested in looking at a specific updates file from raw views here. So what I can do is just to provide a URL there, and then I can add additional filters, and then just parse them all and get a list of messages that are matching. So what I get here is all the messages received from this particular two peers, raw views 2, and then counting them, and not even counting them, just pointing out the messages here. So as you can see, that is actually pretty fast, although it's running on a pretty limited Google Colab instance. Right. What you can also do is to search for like available files that might be of interest. So for example, you want to search for, I think this is the timestamps, same timestamps here. All right. So what I'm doing here is that you can specify start and end timestamps, and then it can either be a Unix timestamp or a RFC 3333 formatted timestamp. And then what it gives you is a list of files that are containing anything interesting or any PGP messages during that time range. So this can be a starting point where, so for each file, you get a URL, get like a collector ID, a rough size that is estimated from their websites, and also which collector project is coming from. Yeah. And then lastly, you can do is to do a historical like RPK data debug, where you want to say, for example, this one asks for what the request has, prefix has, from request has during the date 2008, January 1st. All right, so what you can do here is just basically look for it, and here's a 10 prefixes that are registered on RPK during that date. You can, if you look at the data itself, you can see that it's not only during that date, it's actually still continually existing for these prefixes. So these are still ongoing and then still registered on RPKI. So let's see, let me just 5 more minutes, I guess. So lastly, there's we have a projects.
Mingwei, you're good. You don't need to rush. You're good.
Okay, cool. Yeah. So again, this is open source. I forgot to add the link here. I will add the GitHub link here so you can play with that yourself. So lastly, there's a recent work that I've been collaborating with Internet Society in manners as the kind of a further extending that to be even more useful. So this is an API, a RESTful API for doing all the work that we're seeing before. This is an example where I want to show is to do a event analysis on a control plane for a very well-known events, the YouTube hijack events before. So what I want to show you there quickly is that we have a prefix of interest. This prefix getting blocked. So what you can do is basically, hey, say prefix here, and you can get a time range. So during that time range, it's about 2 hours-ish. There are multiple updates, PGP updates involved in hijack and the counter hijack efforts. Right. So if I'm limiting that to see only the messages for collected from request 1 collector. So what this does is that you can query for all the messages that are within these 2 timestamps by RFC00, and then only give me the file, the messages relating to a prefix. So this is perfect for if you know exactly what you're looking for in terms of an event, and this is perfect. So what it does right now in the backend is that I deployed it on a pretty beefy server at home. What it does is actually pulling a lot of messages in, a lot of files in parallel, and then parse them in parallel so that you can run those things. I can parse all the files and then get only the relevant messages that you want to see. So here's this explanation of what's being returned. So we found 47 messages that are sent relevant to this particular prefix. And you can see all the prefixes there, messages. It's not much, given that it's already 2 hours range. And what's also more relatively interesting is that, so for this particular query, it downloaded 56 files and then parsed about 30-40 megabytes of data. It's not large, but it's actually all done in parallel. So you get those files listed. So if you want to look for any kind of evidences from a particular file, you can go there. One more feature I want to show is that for this particular event, the Google YouTube actually announced a subprefix, which is /25, two subprefixes of this /24. So if you want to look for subprefix as well, what you can do is to also include subprefix here as a toggle. It will reflect on the request too. So what we expect to see is that we're gonna see more messages, and because those messages includes the subprefix announcements there. So if you can see here, we got 47 to 57. So 10 more messages are found because of the subprefixes. All right. Okay. So that's the end of my talk. Again, everything that I talk about in terms of softwares are open source. And if you're interested in getting to know more about that, it's under github.com/phpkit. Yeah, the API is here. You can run it on any of your own instances. It's just a Python library, so it should be pretty easy to deploy. NDTGuide is here with the relatively complete documentation on the page. But note that you can only run the NDTGuide for now on Google Colab due to the authentication limitations. And then many other things that are MIT licensed over there. If you find it interesting, you can go ahead and take a look. And thanks. You can reach me at this email. Again, I'm Mingwei Zhang. I'm kind of the founder of the PHP-Kit. There's an open source thing. We're doing a lot of open source. It's just me. And then I'm currently working as a senior system engineer at Cloudflare. And thank you. I'm happy to take questions.